Hello?
All right. Hey there, Jeffrey. Thanks for joining today's class. Let's go back to, actually, I'll just leave it on this slide. So we're just going to start off with our homework from last week. So this is the very first question of that homework slide. Were you able to attempt this question?
So I just looked at the question and I tried solving it, but I have no idea how to do it.
All right. So that's fine. We can do this together then. Let me know what is the first step that you would take to solve this question.
I guess solve the area for the other triangle that's shaded.
Okay, so find the area of each figure. So we're going to start off with finding the shaded area first. All right, so how would you do that?
I mean, wouldn't you just do like 10 times 15 divided in half, so like 75?
10 times 15 divided by
Wait, no, you
2.
can't do that.
10 times 15 divided by 2. All right, so the thing with that is, hmm, that actually probably could work. I'm just trying to think if that is only available to do for right angle triangles or not. Um, I don't believe you can do that though, because there is other information that we need to figure out as well. So let's see if we can find another solution instead.
No, I have no idea.
All right, so we do have two triangles here, right? We have the shaded version and the dotted line version. So that dotted line comprises of, or actually it makes a larger right angle triangle. So let's start there. Let's see if we can find the area of the entire larger triangle. So how would we find the area of that whole thing, the whole triangle?
You have to find the bottom, but you don't know what the bottom is. Because it only
We
says
don't know.
15 meters for part of the bottom.
Right, right. So we only know a portion of it, but how do we figure out the other portion? Because we do have enough information here. It would be a
Yeah, it's
good place to
8.
start.
The other part is 8, right? Yeah.
So the number 8 is definitely a part of it, but all right, so let's jump into it. Let me just give you a hint. Let me start you off. So that smaller dotted line triangle right here on the right side, we have one side length of 8. We have another side length of 10, and we have a missing side length. We'll call it X. How do we find that missing side length? Well, we can use our equation a squared plus b squared equals c squared. All right, now knowing this information, which um, which values do we sub in? Like where does the 8 go? Where does the 10 go? And where would the x go?
I guess the x at the end of the equation.
Uh,
But no,
x
the
at the
x would go into wait, I'm confused.
all right,
Why
so
are we doing that?
we're trying to find the missing side length, right? This bottom dotted line. And once we find that bottom dotted line, then we can find the area of this shaded area. Sorry, the area of the dotted triangle. And then we can find the area of the large entire triangle. And then we subtract them from each other to find the area of the shaded triangle. Or we can do another method. I'll tell you that after. I don't want to throw so much information right now. But first things first, let's find the three side lengths of this smaller dotted line triangle. And in order to do that, we would have to use a square plus b square equals c square. And to sub in the values correctly, we have to use a little bit of logic. So if we add two things together, it's going to equal another thing. So that other thing, that C value is going to be the largest value, which is also going to be our hypotenuse side length. Therefore, C is going to equal 10, 10 squared. Does that make sense so far?
Yeah.
All right, now A and B, that's going to be 8 squared, whoops, plus B, we don't know yet. So we're going to leave that as x squared. Now,
Okay.
how do we solve this? How do we solve for x?
It's 64. It's 10. It's 100 minus 64. So 36. So it's 6.
Excellent. Very well done. So we got 100 minus 64, and then I'll just skip some steps. We'll go straight to 6. Perfect. So that missing length is 6. So now at the bottom, we have a 6 for the dotted line and 15 for the other line. Um, let's see. So, so let's see if we can find the area of that dotted triangle then. I'm not sure if that's what the question's asking, but let's just do that anyways. Let's find the area of the dotted triangle. We have all side lengths now. We have 8, 6, and 10. So how do we solve this? How do we find the area of that dotted triangle?
I guess you multiply them. Multiply 6 times 8 and then divide it in half. So
Very good. Excellent.
24.
Excellent. Very well done. So area of a triangle equals base times heights divided by 2. In this case, it's going to be 6 and 8. Let me just put those in brackets. 6, sorry, 8, 6 over 2. 24. Looks good to me. Yeah, so that is the area. We've got to put the unit as well. Meter squared. All right, now the area of the shaded triangle. So you are right. We can do base times height divided by 2 for this triangle as well. For the not, right angle triangle, that works just fine as well. The only thing is we have to make sure we're using the correct values. So for the shaded triangle, what is the base value and what is the height value?
15 and 10.
All right, so 15, perfect. That is absolutely correct. 10, unfortunately, is not correct. So do you know why 10 is not correct?
No.
Right, so 10 is actually going in a slanted direction, right? So we can't deal with a number that's going slanted. We have to go with the top point and the bottom point, and we have to line them up in a straight line. Therefore, we'd have to use the number 8 because that is connecting our top point up here, and it's connecting our bottom point down here, but they're going in a straight line. You see that? They're not connecting at a slant, they're connecting in a way that they're kind of stacked on top of each other.
Hmm.
So that's going to be the value 8. So our base is 15, height is 8. Let's find the area of this. Base times height divided by 2. 15, 8 divided by 2.
Um, 40. Wait, no, 60.
Perfect. 60. Looks good to me. All right, so that's it. We're done our question now. So we got the dotted triangle as 24 and the shaded triangle as 60. Um, yeah, so if we only needed to find the shaded triangle, then we would have done exactly as you said, just find 15 times 8, the base times height. But this question's kind of confusing. I think they're asking for both triangles, so we did both. Any questions with how we solved this solution so far?
Nope.
All right, perfect. Let's move on. This time we have a word problem. So a class of 30 students took a math test. The average score was 76%. The teacher forgot to include one student's score of 95%. After adding that student's score, the new average should increase to 78%. So your task is to write an equation to solve the original sum of scores, calculate the new class average, and verify your answer. So this is a key part. Verify your answer is key because I guess we'll see. We'll see. I don't want to give it away. I don't want to throw out the hint, but we'll see why we need to verify. So let's let me just make sure this doesn't take up so much space. Um, anyways, Jeffrey, what is the first step that you would do here?
I mean, I don't really know, but I think you have to like calculate how much each student's like test matters. So I think it's like 3%.
Um, what do you
Wait,
mean by that?
no.
Like how much each
Dividend
student's test
test
matter?
score 76 by 30.
Can
Wait,
you do that again? I think you were cutting out.
I'm so confused.
All right, no problem. So anytime we do these word problems, they could have a ton of information. Let's write down what we know first. So what do we know? Um, I'll start it off. We have a class of 30 students. What else do we know?
That the average test score was 76, but she forgot to include one student that got 95.
All right, perfect. So I'll just put new student as that variable. 95. After adding that student score, the new average should increase to 78. So let me put average
Wait,
new equals 78.
um, is 76 times 30 plus 95 divided by 31 to get the answer?
76 times 30 divided by 91.
Plus 91, no, plus 90, plus 95 divided by 31.
All right, so am I writing this out correctly? Like everything is in a bracket and then all of that is divided by 31?
Yeah.
All right, so what is this supposed to find?
The average with the student that she forgot.
All right, so I'll say new average equals this value. All right, interesting. Um, can you explain this? Because I think we're going to end up with a really large number here. Or not that large, but it's going to be, I don't know, it might not be the
Um,
right value, like the right amount that we're looking for.
You
So
first
walk me through.
multiply 75 times 30 and then plus 95 and then you divide it by 31.
All right. And then you divide by 31. Okay, yeah. So let's see if we can go step by step here because we are kind of combining steps. I don't want to accidentally mess up something and then we end up, having to go backtrack everything. So this, I'll keep it here for now. Let's go step by step. Let's see. We're dealing with the original class first. So we have a original class size of 30 kids, original class score of 76. So let's see what we can do with those numbers. We can find the original total score, right? So we have the average, we have the number of students, so we can find the total score that they all received together. So how do we do that? So just to refresh, we have a
Um, well, 95 times, well, it's 75. But total, I guess you'd have to do 75 times 30.
75 times 30. So it's 76, by the way. The
Oh,
score.
it's 76.
Yeah.
Wait, that changes stuff. Wait, then it's not 75. Okay,
Over
wait.
here is going to be 76.
So 76, because I did the calculations using 75. 76 times 30 plus 95 divided by 31. It's 76. I just got 76.6
Yep. Okay, so that is
as in that.
like we're on the right track. Um, that average that you found, we're on the right track for sure. But I don't want to jump into different steps just yet. I want to kind of work our way up to it. Also, we have to make sure we're using algebra, right? So this is all practicing our algebraic expressions. So we got to make sure that we're able to write these expressions using variables. This is why I put the s right here. That's our first variable. We have s divided by 30 equals 76. And in this case, s represents, whoops, um, let's see, the original score total. Let's say that. All right, so s divided by 30 equals 76. Therefore, s equals 76 times 30. That would be, let's see, 2280. And just like you said, we got to add 95 because that is the new student score. Let's put that over here as well. So s equals 2280. S new equals 2280 plus 95.
Well, then that makes my equation correct, right?
Yeah, so far it's correct. But we got to make sure that we're using our variables in our equation. So your equation logically makes sense, but we are skipping steps and we are missing variables. So try to get into the habit of, doing both of those things. Um, let's see, did I write that down correctly? 2850. I don't know if I got that correct. Let me double check that.
Wait,
Yes,
that's
definitely wrong. All right, so that is our new total score for our class, including that new student. Let's put an equal sign right here. So to find the new average, just like you did, um, sorry, average new equals that new score divided by 31 this time because we have 31 kids now. 76 point something. 63, actually 61. 76.61. All right, so are we good? Are we perfect now? Is this the end of our question?
mm, it says to run an equation.
Yep. So it does say to write an equation, and it also says that after adding the student score, the new average should increase to 78%. So we should expect to have 78%. Unfortunately, we have 76. So that means we got to do this last step. We got to verify our answer. So we got to kind of do something a little different, work a little backwards to see where we messed up. Um, let's write this part down, the verification step. So we should be 78% average, meaning we can work backwards from that. So we can say the same formula here. We have our total score divided by our total number of students, or actually that should be 31. That should equal 78. And I forgot to include this. Our new student, sorry, the new student. New student score is added with our total score divided by the total number of students should equal 78. So does this step make sense right here?
Yep.
All right, perfect. So that's kind of what we're looking for here when it comes to writing a expression, writing an equation for this. So let's solve for S. How do we do this? Let me put brackets here to make it look a little easier to understand.
Um, okay. Okay. First 100. Wait, oh, that's an S. So I guess you can't do that, and you also can't do I guess you can't do the distributive property. Here, I really don't know what I should do.
All right, so we got brackets here, so we can't touch that just yet. So let's deal with this part. We got dividing by 31. How do we get rid of that?
We'll do divided by 30. Move the 31 to the other side.
Yep, very good. So that means we can do S plus 95. That can be on our left side. Right side can be 78 times 31. And then whatever that value is minus 95 will be S. So what is 78 times 31?
78 times 31.
Yep,
Okay, 78 times. It's 2,418.
perfect. And now we're going to subtract by 95.
Subtract by 95.
Yep,
Oh, 2,323.
all right. Excellent. So this should be our total score. So our total score, including the new student, should be 2323. So what does that mean? That means that means after verifying, there must be an issue with the data collected scores. So that's basically just what this question's all about. It's practicing the ability to analyze whatever data that was given to you and to verify if that data is even correct or not. In our case, it's not. It's not correct because it should be 2323. It ended up giving us some other number. Yeah. Um, in terms of your logic, in terms of like how you went about making your equation, it's perfect. You looks like you got it perfectly done. We just have to make sure we're incorporating variables into our answer, okay? All right, so let's move on. Let's go over to our challenge questions now. Here is our first challenge. A cyclist travels 30 kilometers uphill at a speed of 10 kilometers per hour and then returns downhill at 30 kilometers per hour. What is the cyclist's average speed for their entire journey?
Like per kilometer. No, no, like per
Um,
hour.
yeah, so the speed is going to be in units kilometer per hour.
Okay.
I'll write that down. Speed, kilometers per hour.
So it'd be 30, 60 divided by, but it would be 60 divided by 4.
60 divided by 4. Okay, so let's go step by step. How did we get each of those numbers? How'd you get 60? How'd you get 4?
I got 60 because 30 plus 30 is 60. And then I got 4 because in total it's 4 hours. So
All right, so you can do
I think
total
it's
distance.
15 kilometers is the average.
All right, perfect. Uh, so far so good. Sounds fine to me. So let's write this down. We got total distance equals distance uphill plus distance downhill That's 30 each. Yeah, that's 30 each. That is 60. And then can you explain the 4? How did you get 4?
Because there's 4 hours in total that he spent biking.
All right, so 4 hours total. So how'd you get that? Because it doesn't say 4 in our question here, so it is correct, but how'd you get it?
Because um there's he it took him 30 kilometers to get up and he went 10 kilometers per hour.
Yep.
And then after that 1 hour to come down because he rode at 30 kilometers an hour, so 3 plus 1 is 4.
Okay, but where'd you get 3 and 1?
From the 3 hours spent going up and the 1 hour spent going down.
All right, so you're saying the numbers, but you're not saying how you got them. So, like, what is the operation that you used to solve that? How'd you get 3?
Division, I guess.
Division. All right, so kilometers. Sorry, 30 kilometers is our distance. Speed is 10 kilometers per hour. So the important thing that I wanted to point out with this question is the units. And you're doing everything correctly. You just gotta really make sure that you're explaining it and writing it out so that the teacher knows, when you're doing this on a test, you don't lose marks for just only stating the answer. You get full marks for breaking down every step. We got distance, we got speed, we have distance is kilometers, speed is kilometers per hour. Speed equals distance divided by time. So in this case, we
Mhm.
have 10 kilometers per hour equals 30 kilometers divided by whatever our time is. Time is still unknown. So we can solve for t. How do we solve for t? You can say, let's see, you can do, whoops, 10t equals 30, and then t equals 30 over 10. T equals 3 hours. As you are writing this out, you'll notice that the units are attached. The units never leave. So you'll do 10 kilometers per hour equals 30 kilometers. Then you can do 30 kilometers here divided by 10 kilometers per hour. And you'll notice that kilometers at the top and kilometers at the bottom, they cancel out because you're dividing them by each other. So kilometers cancel it out. You're only left with hours. Therefore, t equals 3 hours. So that's correct. Perfect. Um, Traveling the same distance, I guess, at 30 kilometers per hour. Yeah, so you can just repeat that same step. Repeat the above steps using speed of 30 kilometers per hour to find time of 1 hour. So total time is 4 hours. Then we do 60 kilometers per hour. Sorry, 60 kilometers divided by 4 hours equals our final value of 15 kilometers per hour. All right. So this question was mainly just to focus on units, focus on how to cancel out units, how to logically formulate our equations using these units. And yeah, that's about it. So try to do, I don't know, if you're writing these all out, which I recommend, try to write it out step by step so you know where the units are going, which units are being canceled out, and which units remain. Does that make sense?
Yep.
All right, let's move over to our next question. Another question that deals with percentages. So we have a juice company wants to mix two types of fruit juice. Apple juice is 40% sugar, Orange juice is 20% sugar. The goal is to create 30 liters of a mixture that is 32% sugar. How many liters of juice, sorry, how many liters of each juice should be used? All right, so
I think I know how much should we use, but I don't know how to turn it into an algebraic equation.
sure. So let me know what's your answer so far?
Wait, it has to be like 1614 or 1812. That's just what I know. Wait, if it's 1812, because okay.
Okay, so 16 or 14. I'll just put those splits down, 16, 14, 18, 12. Either
I
one of
think it's
these could work.
1614.
16, 14.
Wait, no, no, wait, it could be both. Wait, I'm really not sure actually.
Yeah. Okay. Yeah. No problem. So, I don't want to do, trial and error for these type of questions. It's fine to start off, just to give yourself like a nice benchmark of what to look for. But overall, though, that can't be our final answer. So we need to include step by step. First things first, let's write down what do we know.
Apple juice contains 40% sugar, orange juice contains 20%, and we need to make a mixture that contains 32%.
Perfect.
And it has to be 30 liters.
Excellent. So orange juice is 20. Yeah, 20%. Um, I'll say final should be 32%. And final amounts should be 30 liters. Um, Another thing that we need to find is apple juice amount is a question mark, and orange juice amount also question mark. We don't know those. So we got to figure out these two values. So how do we do that? Um, yeah, well, what do you think is the first step here?
Well, I mean, you had to create an equation, I guess.
Yep, excellent. Create an equation. We're going to need two equations here, but what is the first one that we can do?
I have no idea for any of them.
No worries. So, as I've said before, a common hint here is to look at the totals. So we have one total here, total or, final values, whichever one you want to say. But we have a total value here of 30 liters and another total value here of 32% sugar. Which one of these can we use right now to create an equation?
Both?
Yeah, you can use both, but okay, I'll word that a little differently. So each one of these is going to create its own equation. So this one creates one equation. This one creates another equation. I'll do the bottom one first. I'll do the amount equation first. So the reason I'm pointing out the totals is so that we know what is on the right side of our equation. The total is always going to be on the right side. So I'll put equals 30 for now. That is our right side of our equation. That is the total amount of juice. So how would you find the total amount of juice? What is comprised of the total amount?
I guess, like, wait, total amount? Like, how? Can you repeat it?
Sure. So we're trying to find the total amount of juice. So how would you find that? What is the total amount of juice?
30 liters
Yeah.
for the final amount?
Yep. Perfect. So 30 liters is fine. But how do you find that though? how do you calculate 30 liters?
Is it like a conversion thing?
Okay, not quite. I think we're going a little too deep into this. The total amount of juice is simply just the amount of apple juice plus the amount of orange juice, right?
Yep.
All right, very good. So that is our first equation. I just put it as A plus O equals 30. Now, what is the second equation? As I mentioned, it's going to equal 32%. I'll say
So,
0.32.
well, like when you say like um 0.4a plus oh no, wait, what do you say like 0. Oh, a 0.4a times 0.20 equals that.
Very good. 0.20 equals this. I am missing one thing. This should have another value. So we have our percentage times our amount, right? So we have our percentage of 40% times our amount, apple juice amount, percentage times amount, percentage. We're missing our amount. I forgot to put 30. 30 liters is our final amount. So this is our second equation. So we have two variables, two equations. We can solve this. All right, so how would you solve this?
Well, I mean, wouldn't we just have to solve the bottom one first? Wait, yeah, you
So,
have to,
yeah, go ahead.
because it's gonna be very hard to. Okay, wait, doesn't that just mean like for the bottom one? Doesn't it just mean like 0.32 times 30?
0.32 times 30. Yeah, so that is the right side of the equation.
So should I do it?
Yeah, sure. No problem. You can do that.
So 0.32 times 30, it's 9.6.
All right.
That's what it says.
All right, not bad. So 9.6 makes it a little easier to look at, but we still have two variables and we still have two equations. So what do we do here?
Now I'm stuck.
All right, no worries. So when we have two equations and two variables, we have to um, we have to write it in terms of one variable. So let's choose a variable here. I'll just choose A. And I'm working with this highlighted equation here. If I'm going to have A isolated all by itself, what is on the other side of the equation?
The other side of the couldn't you wait would be like 30 minus O.
Perfect. 30 minus O is absolutely correct. Now, using this new formula, or sorry, new equation, we can sub this into the second equation. I'll say equation B. So this I'll call it B, and whoops, this I'll call it A, or actually, yeah, whatever, I'll just call it A. So we can sub this guy into equation B. What would that look like?
Wait, sub this equation. Oh, wait. Okay, 0.4. Wait, 0.4 times 30 minus O plus 0.20 equals 0.32 times 30. Is that right?
0.32 times 30. Yep, perfect. Excellent. Everything is very well done. You can also just simplify it to 9.6 because we already found that. But yeah, very well done. This step right here of subbing it in is vital. Now, what is the next step? How do we solve for O?
Okay. No, this is the part where I have no idea on. Wait, you have to do the distributive property.
Yep, perfect.
0 point, but what's I'm gonna use a calculator for this. 0.4 times 30, 12. 12 times 0.40.
12. Wait, so 0.4 times 30 is 12?
Yeah, I used the calculator.
Okay, perfect. And minus 0.40 plus 0.20, oops, equals 9.6.
Yeah.
All right, excellent. Let's keep it going. Oh wait, no, I forgot O right here. All right, what's next?
Okay. Oh, you have to combine 0.40 with 0.20 to create 0.60.
0.6, so it's going to be a negative sign here, and then a positive sign.
Oh, 0.2, but negative
Yeah,
0.2 oh.
nicely done. And a
Wait,
couple more
do you
steps.
move the 12 to the other side?
Sure.
Right, yeah. So and that's minus, so negative 3.6. Okay. So
3.6.
that means that,
Wait, let's double check if 3.6 is
wait,
correct.
it's not 3.6. No, I messed up. Wait, what is it? I think it's, wait, 2 point, oh,
2.4.
wait, is it 2.4? Yeah, it is 2.4.
Yep.
So that means, it's 12.
12? All
O
right.
equals 12.
O equals 12 looks good to me. O equals 12 is our first variable. Now let's use that information to find our second variable.
The second variable, it's well in the equation it says a plus o equals 30, which also equals a equals 30 minus o, so that's 30 minus 12, which means a equals 18.
Excellent. A equals 18. I'm just going to write it out. All right. So we have O, we have A. Yeah, I think that's it. That's it for this question. So we have 18 liters of apple juice and 12 liters of orange juice to create the specified mixture. All right, excellent job. Any questions with how we solved this?
No.
Awesome. So um, let's see what's next. Actually, let me leave this one for homework. Let's shift gears to a little bit of geometry mixed in with our algebra. So these two questions right here, these two diagrams, we're going to see if we can find the value of x. So in each triangle, the measure of angle A is the same as the measure of angle B. So our goal is just to find what is the value of x. Let's do the first triangle here.
So value A and B are the same?
Yep.
Okay. That means that, okay, if they're both the same, that means that it's 63. So what times 3 equals 63?
Okay,
Oh,
so
geez. Oh, 21? X
21.
equals 21 then?
Sure. So
Yeah.
how did you get there? We're missing one key step to start things
You
off.
said A and B equals the same thing.
Yep.
So assuming that it has to equal 70, I just kind of like move the 7 to the other side, so it's 63. And then 3x, I know that 3 times 21 is 63.
All right. So even though logically everything you said makes sense, we have to make sure we actually state this portion right here. This highlighted portion that 70 equals 3x plus 7. Because you're talking about dividing 63 by 3, all of that is fine, that's perfect. But let's make sure to include this step too. So x equals 21. I think that's it. That is the final answer. Sounds good to me. Let's work on the second question.
So A and B equals the same thing on this one too, right?
Yep,
Okay, well I'd have to do the same thing. Right. So you just don't you just state the question first? So like 45 equals 4x plus 3.
yep,
And then you move the 3 to the other side to make it minus 3. So 42 equals 4x. And then, um, oh, it's a decimal. It equals um 10.5.
10.5. Yeah, looks good to me. So it's 21 divided by 2. Yep, sounds good. So x equals 25. Perfect. Very well done. Let's go to the next slide. So here we're just practicing roughly the same thing, but everything has a fraction. So fractions equals fractions, fractions equals whole numbers, whatever it is. Let's do question. Let's see. Let's just start off with question 26. Let's go there.
26. Okay.
So we got
Y.
over.
So y over 4 divided by 2 equals. Can you move the 2 to the other side?
Yep. We're gonna move the
So
2 to the other
that is
side.
it's y minus 4 equals 20.
Perfect.
Okay, so that means y equals 24.
All right. Excellent.
That
Very
was
well done.
easy.
Yeah, pretty straightforward. Let's do. Let's just go 28.
Okay, so that's x plus 10 divided by 9 equals 2. Okay. So I guess we just move the 9 to the other side again, right? To make it 18.
Yep.
So now we know that x equals 8.
X equals 8. Perfect. Let's see. What else can we do? Whoops. All right. Let's go with 30. So we have 7.5, or sorry, 7 and 1 over 2 equals x plus 3 over 2. Let me put the brackets here as well. All right. So how would you solve this?
I'd move the divided by 2 to the other side.
Yep.
Can you do that?
Sure. Yeah,
That'd be 15.
that would be 15.
Yeah, 15 equals x plus 3. So now I know that x equals 12.
X equals 12. All right, looks good. So this equals 15. That's fine. So we have 7. We're looking at 7.5 times 2. So this, not too sure if this is actually correct here. So 7 and 1 over 2 is actually the same as saying, what is that?
7.5, right?
7 and 1 over 2. That's the same as saying 15 over 2, right? Yeah, that's the same as saying 15 over 2.
Really?
Yeah, because
Oh.
7.5,
Wait, that's
yeah, 15 over
interesting.
2 is
No,
also.
it would still be 15, right? No, it would just be 30 over 2.
So 7. Okay, so if we're trying to convert a improper fraction to a mixed fraction to an improper fraction, we have to multiply the whole number times whatever the denominator is plus the numerator, correct?
Yeah.
So 7 times 2 plus 1. That equals 15.
15.
Yep. And denominator always stays the same, so it's 15 over 2. Therefore, 15 over 2 is right here. The right side, I kept it the exact same. I only wanted to change the left side for now.
Well, then
So
it'd be 30 over 2, right?
um, it would just be 30. Because, no, sorry, it would just be 15 equals this. So take out this, take out this.
Oh, so that's just an extra step to make it more clear.
Yeah. Okay, yeah. So the answer that you got is actually the exact same. Okay, yeah, I was just getting mixed up with. Okay, yeah, that's my bad. I was just getting mixed up with the fractions. Yeah, x equals 12. I think that's what you got initially, anyways. Nicely done. Let's do let's do the last question. 33.
Is that hard? No. It looks harder. Okay. Um, G minus 3 divided by 3 equals, okay. I move. Can you do like the improper fraction thing again? Oh wait, it's already improper, so you don't need to do that. You move the divided by 3 to the other side to make it just 5,
Yep, perfect.
and that G equals 8.
Yep, G equals 8. Sounds good to me. So I am
Okay.
gonna continue for another 5 minutes just because we started a few minutes late. So
Mm-hmm.
let's do a couple of these questions too.
Got it.
Let's
Which
go
one?
with uh let's see, let's go 41.
Okay. So it's 1/2 C minus. Okay. Yeah, this looks Wait, is it like the C connected to the? Oh, it's just times.
Yeah, it's multiplied. So you can just say C over 2. That's another way of saying it.
Wait, is it? No, no, you can't do that. Can you move the -2 to the other side?
Yeah, you can do that. So it's going to be 1 over 2 minus, or sorry, plus 2.
So that's well, no, you can't do 2 and 1/2. It's 5 and a half. 5/2.
Yeah, sure. So it's 5 over 2. Um, if you wanted to include the extra step, you could have said 1 over 2 plus 4 over 2, but that's extra. We don't need that. So 5 over 2 equals C over 2.
Wait, C equals 5 then.
Excellent. C equals 5. We can always just cross out both of these denominators because they're the exact same. C equals 5. Let's see. What is the next question? I'll go 42. Very next question. X, whoops, I wrote that incorrect. X minus 3 divided by 3 equals negative 4 and 1/2. All right.
Well, first of all, you need to convert 4 and 1/2.
Yep.
So that'd be 9 and 1/2. 9/2.
Excellent. So it's still going to be a negative. So it's negative 9 over 2. All right. What's the next step?
I'd divide. I'd multiply 3 by it.
Sure. So we can do x minus 3 on the left. And
So
then
that'd be 12. Wait, no, that'd be not. Wait, 4.5 times 3. Okay, that's 13 and 1/2, which equals 27/2.
27 over 2. Negative 27 over 2.
Oh yeah, negative, and then something minus. Okay, so that's 13.5. 13.5.
13.5. Okay.
Oh, 10.5. Negative 10.5.
All right. Excellent. Negative 10.5. All right. Very well done. Let's do another one of these. Got a couple minutes left. So I'll go question 44. We got D plus 17 divided by 2 equals 5 and 1/3.
Okay. So you got to turn that into improper. So 16 over 3.
16. Yep, looks good to me. 16 over 3. Let me just copy this left side here. All right, next step.
So you move the divided by 2 to the times 2 to the divided by 2 to the other side, so it becomes times 2. So it'd be 32 over 3.
32 over 3. Yep, looks good.
Okay, and then that would be something. Okay, so that'd be that minus, wait, 32 and a half is really just 10 and 2 over 3, right? Yeah.
Yeah,
Wait,
so
that's the
well, just
negative
going
number.
forward, yeah, with this fraction right here, I guess we can just leave it as a fraction, or you can just punch it into your calculator. You don't really have to know like the mental math for this type of question. But this is going to be really close to 11 because we know 33 divided by 3 is 11. So 32 divided by 3 is real close to it, just under it. So 11 minus 17, let's just say that. It's going to equal
It's negative 6 point. It's negative. It's negative 6 and 1/3.
-6 and 1/3.
That looks correct. Yeah, that's correct.
Um, yeah, all right. I'm good with this. This sounds good to me. So it looks like we just converted this to a mixed fraction and then we subtract by 17. That's fine. All right, so that is the end of today's class then. Let's see if we can assign some homework. So here's the first homework slide. This word problem right here, you can screenshot this.
Okay.
And I'll just write down
Got
homework at the end. All right, did you get it?
it. Yep.
All right, perfect. And let's go with,
Oh, which one?
you can just go with the questions that we didn't do here.
Okay, here, I'll do that.
Yeah, questions that we did not complete is for homework.
Mhm.
All right, good.
Yep.
All right, perfect. So that's it for today's class. Great stuff, Jeffrey. We'll continue with these topics for next week. Yeah, I'll see you next week. Take care.
Bye. Thank you. Have a good day.
Thanks, you too. Bye-bye.
Bye.